The U.S. Department of Energy is cleaning up the Oak Ridge Reservation of residual hazardous and radioactive contamination left over as a result of decades of nuclear energy research. Much of that work has been influenced by the Oak Ridge Site-Specific Advisory Board, a citizens panel that provides independent advice and recommendations on DOE's cleanup operations. You're welcome to attend the meetings and be part of this important work.
Well, thank you for everyone that's here and online. Go ahead and start. I guess we'll go over to this side. Jay, you want to start?
Yes, sir. Appreciate it. So first of all, again, thank you all for spending your time here on the evening. I know you're not paid for this, so we certainly appreciate the volunteerism here. I did want to bring you up to speed on a few things since the last time we were here. So you may recall back in September, we started on the ancillary building at Alpha 2 for D&D at Y12. In fact, today we actually started tearing down the main building. So pretty big milestone for us. That's the first major mercury use building that we will have started on at Y12. So pretty happy about that. As well, y'all may have heard about the Dara Soils building in the past. It was a building where some soils that we got rid of were stored. We are in the process of turning that into a test bed where we can bring in different technology and do technology development for helping us with some of the mercury issues that we're having out at Y12. So that construction has started and we're about a third of the way into that. You may have seen back in the end of October, we did a community roundtable here on developing future workforce and bringing folks along. That actually was, I think, pretty well received. It got some interesting feedback for EM headquarters. We were the third or fourth site that they've done that with the community. And so I think of all the communities, how truthful this is and how much is it to make me feel good about hosting it here. But from headquarters perspective, at least what I've been told is we're one of the communities that gave the most interesting feedback and had the best participation. So I was pleased with that. And then finally, I know y'all been tracking the 42 million NRDA settlement. I think we're getting to the point here soon where we'll be able to have some community workshops on that to explain a little bit better. And the dates I've got, which always may be subject to change, but it looks like we're going to start mid-December. So December 12th and January 9th and 23rd. And we'll hold them in various community centers. Here in Oak Ridge, it'll be at Town Place Suites. You don't need to write this down and get you this in. So, in Kingston will be at the community center and then up the Holiday Inn in Clinton. So we're trying to cover kind of the waterfront, at least with the initial tranche of these to get out public. So with that, unless there's any questions on any of that, I'll turn it over to Sarah, who's going to talk, I think, a little bit about what's going on with Isotech.
Absolutely, Joe. Thank you.
Won't read her. Harry's going to read your bio.
No, never mind.
You guys have it.
Turn it back over to you.
Yeah.
How about that?
Walter, do you have anything?
No, Jay did a wonderful job. Thank you.
Sorry.
Yeah.
I don't have any comments.
Yes, I see we've got Samantha, online. Do you have anything, Samantha?
Sorry. Yeah. I don't have anything. I apologize for not being there in person, but I injured my back the other day and so hope to be there for the next meeting.
Yes, thank you for being online.
Yeah. Sit down.
All right, we'll turn it over to Spirits.
Okay. I'm introducing Sarah. Sarah Schaefer is the president and project manager at Isotech Systems LLC. She was named president in February of 2024 and has worked on the U-233 disposition project for 16 years. Beginning as a nuclear facility manager and progressing to operations manager, and then to her current role where she is responsible for oversight of operations, security, performance assurance, nuclear safety, and financial performance on the project. Previously, Sharon was assigned to manage the startup of the U-233 dissolution and thorium extraction operations in glove boxes as part of a public-private initiative with DOE. Sarah has more than 30 years of experience focusing on safe and compliant commercial waste and nuclear waste disposal operations. She has worked in this capacity for a variety of companies and previously managed DOE's Environmental Management Waste Management Facility, the EMWMF, nuclear disposal facility, and the Oak Ridge Reservation landfills. Sarah has a Bachelor of Science in Civil Engineering from Valparaiso University, which I checked is in Indiana.
It is in Indiana.
Okay.
Thank you for being here.
Thank you. Thank you. So just since I've been at Isotech or on the U-233 disposition project for 16 years, the project means a lot to me. It's and I'm really excited to share where we are in the disposition and share a little bit about what we're doing with thorium extraction. And so Isotech Systems has had the project to disposition the uranium-233 inventory at Building 3019 since 2003. The first several years, we were not at ORNL. We were doing more design work and programmatic development work, but moved to the facilities or moved to Building 3019 in 2007 to pick up the management of that facility. We are a Isotech LLC. Originally was 3 companies that came together, but in 2012, our mothership bought out the other 2. And so we are a wholly owned entity of Atkins Nuclear Secured Holdings, and which is owned by Atkins Realis, which is a Canadian company. Our mission is to disposition the inventory at 3019. Originally, it was to design the process by which we use now and to safely dispose of the downblended waste. We have 185 people who work at Oak Ridge National Lab and our facilities there. As you can see, we've got 2 nuclear facilities in the what I presented to the SSAB chairperson meeting was this is the vintage area of Oak Ridge National Lab, but the historic area up in the northwest corner, Building 3019 there, and then directly across the street, Building 2026. Building 3019, just as, though I'm sure many of you know this, it was one of the original Manhattan Project buildings built in 1943 and commissioned that year. It was a pilot plant for many radiochemical processes that then went on to be used at Hanford and elsewhere. And in 1962, it was designated as the uranium-233 repository, and it received material for storage up until 2008. Actually, it received its last canisters about 2 weeks after I arrived at the building. It is the oldest operating nuclear facility in the world. So the inventory, it is heterogeneous inventory, originally 1,098 canisters, which are different shapes and sizes, different configurations of solid material. And because of that, the design of a processing facility that could handle all of the different types became challenging in a 1943 vintage facility. And because of that, the department undertook an alternative analysis, and it was ultimately determined that about half of the material could be direct disposition without any processing, and that the remaining half then would need processing to be able to meet security and safety requirements. So just as between 2011 and 2017, the direct disposition campaign occurred where all of the consolidated Edison uranium solidification process material, which in that picture, let's see if I can do this. No. how did the pointer work again?
The button on top, the first button, hold it down.
Okay, which that, like that, those are about 24-inch canisters. That's a stainless steel pipe. It is a ceramic monolith on the inside. 402 of those were pulled out of storage and shipped out west for disposal. We then had, prior to that, zero power reactor plates, which were stored in containers that look like this. Looks like a juice can. Individual plates were in there. 126 of those were transferred to the device assembly facility in Nevada. And then we have a small population of very pure uranium-233 that Oak Ridge National Lab identified for use in certified reference material, and all but 2 containers of that have been transferred to Oak Ridge National Lab for their use, which left nominally 500 canisters of material that needed to be processed. We started processing oxide powders in 2019, and I'll get a little bit more into that here in a few. And the next material, which looks very similar to the cuss material, ceramic monoliths, will start to be processed at the beginning of next year. All right, building 2026. So until 2017, we only operated building 3019. To process this material, we needed hot cells. To do that, when it was determined we couldn't construct a processing facility inside building 3019. And directly across the street was a facility that had been operational through 2006. That didn't have a mission at the time. It's sort of on the list to be torn down. And we were able to get that transferred from the Office of Science, or DOE was able to get that transferred from the Office of Science for use as the U-233 processing facility. So a little bit about uranium. Uranium-233 specifically is a man-made fissile isotope. It was produced originally to begin with in the late 1940s. And they thought they would use it for both weapons and for reactor fuel. But in most cases, there is a uranium-233 contaminant in with it, which makes this material high dose. And you need to have shielding to be able to manipulate it. And it was decided that it did not have a mission use, and which is why it was sent to Building 3019 for storage. But one of the daughter products of uranium-233 is thorium-229. And Oak Ridge National Lab, which received about 1/4 gram of thorium-229 from the U-233 inventory at ORNL, piloted the separation of actinium-225 from thorium-229 in the 2010-2011 timeframe. So the Office of Science really kind of kicked this whole thing off. And with a small amount, the 1/4 gram that they had, fed the medical research and clinical trials that took place up through the end of last year. So TerraPower Isotopes, company in Everett, Washington. Chairman on the board is Bill Gates. Approached the Department of Energy in 2015. So while we were in the middle of our direct disposition campaign, knowing that the nation's inventory of uranium-233 sat at Oak Ridge National Lab and was in the middle of being disposed of, and asked DOE if they could add thorium extraction to the process so that this thorium-229 could be saved. Negotiations went on for a couple of years while we finished direct dispositioning the half of the inventory. And what resulted was a partnership between TerraPower and Isotech and the Department of Energy that allows us to save the thorium-229 from the remaining inventory and offset the costs of the Department of Energy's for the dispositioning this material. The challenge that TerraPower gave both the Department of Energy and Isotech when the agreement was signed in 2018 is that they wanted thorium within basically 1 year. And at that point in time, we had just moved into building 2026, and the process, the design wasn't quite done yet, and certainly the long lead procurements hadn't quite been initiated. And I know this is hard to see, but really it's the green and blue areas. So we took a look at the inventory that sat at building 3019 and identified a small population, nominally 50 canisters of the 500 that were remaining then, and said these have a small enough amount of 232 contamination. So they were low dose material, could be contact handled, that this material could be processed in glove boxes, which we could put into play much faster, while the design was being approved by the Department of Energy for the hot cell processing. So in the blue area was the area in building 2026 where we were able to put shielded glove boxes, while the construction of the downblend system, the solidification system, the recirculation system, and basically the cleaning out of 5 hot cells that hadn't been used since 2006 took place. So both things were able to go on at the same time. The glove box processing was called Thorium Express, and it really became a pilot project for us. The equipment used in Thorium Express was funded by TerraPower. Since this was not an original concept with the Department of Energy, we were able to use their money to have the equipment fabricated, most of it fabricated here in Oak Ridge. We were able to put in the glove boxes, the equipment we would ultimately use in the hot cells, and it allowed us, because that's more of a contact handle, much easier to operate using gloves than manipulators. We were able to really fine tune the process over an 18-month period where we processed 27 canisters, extracted 1.67 grams of thorium, which doesn't seem like a lot, but that was 95% of what was available in the material processed. And because that we were able to get started about a year early, also under the cloud of COVID, COVID came into play right after we started glove box processing. This initiative for Thorium Express was received the Department of Energy's Achievement Award, as well as we were able to host a celebration here in Oak Ridge, which really highlighted, here's a Cold War era material that where something that might be able to save lives is being saved and being handed over to a commercial entity to go work that. So the second answer, the first answer being you could process nominally 50 canisters in glove boxes. The second is outfitting the hot cells to handle the higher dose material, basically the rest of the inventory at building 3019. We installed, let's see here, we installed all new manipulators in every single, in these 5 hot cells. On the back side, right up here, we removed 2 of the hot cell shield plugs and then had installed a cell portal, which allowed the pass-through of canisters into the cell, as well as the removal of debris from the cell. We installed the solidification system, which is right here on the northwest side of the building, allows us to bring in depleted diurnal nitrate tanks. The conversion of DUO to DUN occurs here at MSC in Oak Ridge. Anyway, those tanks come in there. So we created shielded areas for that material to come in and get hooked up so we could recirculate it for the ultimate down blending. And then the solidification silo was installed outside the facility. And rather than me talk through what the process looks like, we have this video that I'm going to show, I think.
The U-233 canisters will be processing in hot cells will be much higher in radiological dose than those processed in glove boxes. Because of this, they will need to be packed into lead-shielded carriers in our Building 3019 storage facility. The overpack and carrier weigh thousands of pounds, so a forklift is used to transport the canister to Building 2026 where processing will take place. Once at 2026, the overpack is removed. The carrier will then be moved into place in front of the hot cell portal to prepare for canister entry. A special lifting device is used to lift the carrier that envelops the trunnions on its side. This special lifting device also allows the carrier to be rotated once it's lifted and laid on its side onto a cradle attached to the hot cell portal. The cradle is lined up perfectly with the canister-sized port. It is then pushed to the port, and using a tiny opening in the bottom of the carrier, the canister is pushed out of the carrier, through the port, and into the hot cell. Hot cells are ideal for processing because they provide significantly more shielding than glove boxes. From a safe distance, operators will use mechanical arm manipulators to handle radioactive material. So now that the canister is safely in the hot cell, operators will use manipulators to pick it up and cut it open. They'll remove a container holding U-233 from the canister and then dispose of the canister in a debris drum underneath the hot cell pan. The U-233 will then be divided into batches to be transferred to the neighboring processing cell. This is done by placing the batch into a sliding door on the side of the division cell that goes through to the processing cell. Just like in the glove boxes, the U-233 will be mixed with nitric acid, creating uranyl nitrate. It's pumped through the transuranic column, where the resin inside captures transuranic elements to separate it from the uranyl nitrate. After that, it's pumped through the thorium column, and thorium is separated from the uranyl nitrate. The U-233 is singled out now in a dump bottle after passing through the columns. We'll be downblending it further, though, by circulating pre-made depleted uranyl nitrate through piping in the hot cells. This circulation generates pressure that will suck the uranyl nitrate out of the hot cell into the recirculation system and through to the waste tanks in another area of Building 2026 where the depleted uranyl nitrate originated. Adding processing waste to the depleted uranyl nitrate creates downblended uranyl nitrate. Once a tank reaches a specified amount of waste, the contents will be solidified. To do this, a fill head is lowered on top of it and cement is transferred from a silo outside of Building 2026. Thousands of pounds of cement will be transferred into the waste tank, and mixing blades inside will mix the waste with the cement until it is a solid piece of concrete. Now that it's prepared for shipment, it just needs to be moved onto a shipping truck. The waste tanks sit on air pallets that will allow operators to move these massive structures weighing tens of thousands of pounds. Because of this, a tank can easily be moved outside of Building 2026. A crane outside will then lift the waste tank off the air pallet and place it into a shipping cast on a transportation truck. The U-233 waste is then transported to a disposal site. That's only half the process though. We still want to get that thorium so it can be used for cancer treatment research. To get it off the resin column, a different concentration of nitric acid is run through the column, releasing the thorium from the resin. The thorium and nitric acid solution is then pumped into an evaporator that is heated until the nitric acid evaporates away, leaving just the thorium from the column remaining. This used to be our last step when we extracted thorium in glove boxes, but we've since developed additional methods to separate even more of the uranium from the thorium product. So nitric acid is put into the evaporator flask, making a concentrated form of the thorium and nitric acid solution. Then it's pumped into a new column, the thorium concentrate column. Thorium is also attracted to the resin in this column, and the nitric acid with small amounts of uranium passes through and is downblended. To get the thorium off this column, hydrochloric acid is added to release the thorium. That solution is then pumped back into the evaporator. Once again, the solution is heated until the hydrochloric acid is evaporated, leaving thorium with an even smaller amount of uranium remaining. Hydrochloric acid is added again, and that solution is pumped through one last column, the thorium polishing column. This time, uranium is captured by the column. So the solution can be pumped to the evaporator. One last time, the solution is heated, leaving just the thorium product. This is, by and large, the only available thorium-229 in the world. So the work we do here has the potential to make an incredible positive impact on cancer treatment research.
Okay, so I think everybody on Teams and here can then see the slides again. So that explains the process. So we finished processing in glove boxes in the summer of 2021. Commissioned the equipment in the fall of 2021 and began the readiness process starting in 2022. We received authority to start up in October of 2022, so we've now been processing for 2 years. It was a very slow startup period. We started at one end. There were two operating areas, the east and the west. We started at one end, showed that we could do it without issue, kind of from a conduct of operations standpoint, moved to the east end, brought that side up, and then started operating in both sides by March of 2023. TerraPower, after the initial request for us just to extract the thorium, by the time we got to hot cells, they were wanting us to do the purification, which is where we bring in the hydrochloric acid. So they paid for the refurbishment of the 6th hot cell at Building 2026, basically a new shield window, new manipulators, new portal on the backside, so that we could bring the extracted thorium there and do the purification. Certainly in this 2-year period, we've learned a lot. Most of it within the first year. The manipulators, though we had trained, a lot of folks, we did not have people who had tremendous amount of manipulator experience. And so manipulator repairs became a challenge for us, and that was provided. We purchased manipulator repairs from Oak Ridge National Lab. We found later on that we really needed to bring that in-house. So we've trained 4 very talented millwrights right now to be our manipulator repair folks. And we brought, our manipulators are made in Germany, and we brought over technicians from Germany to do that training. In the 2 years, and actually I'm going to give you a more current number, we have processed 47% of the initial processing campaign material. The IPC material is the oxide, it's the powders. So we're making good headway. We've extracted, I just got an update today, 11.99 grams, almost 12 grams of thorium-229 between the 2 campaigns. And 11.5 of that has been transferred to TerraPower. And our extraction efficiency right now is at 89%. When we started the hot cell processing, it was in the low 80s, and we've slowly built it up. Learning how many batches we can put on a resin column, and encountering some material, we knew the quantity of uranium in the canisters, but there was something called diatomaceous earth that was in there, and a few other things that caused us to lose a little bit of thorium in the process, but learn from it before we get too far down the road. So let's talk a little bit about the thorium and what TerraPower is doing with it. So between 2019 and really the middle of last year, TerraPower stored all the thorium that we gave to them. In Washington State, they were in the middle of licensing a brand new laboratory. And that took a little bit longer than they thought. So in the middle of last year, they started unpackaging the material that we sent to them. Most of it they've kept at their laboratory, though they do have a partner with Cardinal Health, and some of the raw thorium-229 has been sent to Cardinal for them to put on the thorium generators. TerraPower and others milk the thorium-229 for the actinium-225. So the thorium does not go away. It regenerates the actinium, so it's not like a milligram of thorium used up when they're extracting the actinium-225. This material will last beyond my lifetime. But when they extract that actinium-225, they have nominally 10 days to get it into the hands of those who will use it. That's the half-life. And the actinium-225, and this is very layman's because I am not on that side of the process, but they attach it to a chelator or a molecule that is uniquely selected to seek out the cancer cells inside the patient. And because the actinium-225 is a high or a high dose, but a very short half-life, it does, and it's an alpha emitter, it does very little damage to the surrounding cells, which is why it's been identified as a future treatment for cancer. So where is TerraPower in all of this? And this is really hard to see, so I'm gonna, I apologize. Let me see if I can. They are partnered with companies like Bristol Myers Squibb, AstraZeneca, Raise Bio, and others who are in various stages of clinical trials, which is what this right over here shows. It shows this is pre-clinical in the light blue, and then you get into phase 1, phase 2 in the more royal blue, and then the darker is phase 3 and that, or 2, and then phase 3 is the green. And phase 3 clinical trials is when they're actually using material on humans. So the material that Isotech extracted and has sent to TerraPower, they have milked it for actinium-225 for various stages of these trials. But as of about 2 months ago, it has made it to people who are using it in phase 3 clinical trials. So it's actually being used in humans, which is very exciting for those of us who go and work on this project every day. And so the results, now these are not results from TerraPower's material. This is early, this dates back to, you can't see I want to say 2016, am I right in that? I believe 2016, where it was used on prostate cancer. And in the view in A is what the patient looked like. And the dark areas are cancer cells after, 2014 and 2015, sorry. And in 2015, they had their first dose, and within the next time they had a scan, the cancer had been reduced to that level. And then again, in September of 2015, they had another dose and were shown on that. Were shown to be no continual spread, but in a concentrated area where they could continue focusing the treatment. This is really this trial occurred in Germany, I believe. It was definitely Europe, Northern Europe. And this is really what led the industry to get excited about the targeted alpha therapy and the use of actinium-225. Raise Bio, Dr. Ken Song was here for an event that we had last April of 23, right, Jen? And he had used a little bit of the material that had come from Oak Ridge National Lab, the prior material, on pancreatic cancer, the same kind of cancer that Steve Jobs had. And had found on several of the patients that they had that they were able to eradicate this certain kind of tumor in pancreatic cancer. So there is tremendous hope out there for the use of this material. Ultimately, when Isotech is done processing and disposing of the uranium-233 at Building 3019, there will be nominally 40 grams of thorium-229 available TerraPower will have. Again, the half-life of the thorium-229 is like 160,000 years. So there's, this little bit of material is paving the way. Now, there are others that are working on the generation of thorium-229 from not starting with uranium-233, and through positive outcomes from these trials and from the use of this material to really kick off this industry and potential hope for cancer patients, there will be more funding potentially available to support the development of that thorium-229 generation. That's where we are.
We'll take questions from the room here, the board members. You guys have any questions?
I do.
Yeah, sure.
Sounds like a chemical engineer's dream. Being a chemical engineer, I can identify with much of that processing, but I was just interested in what do you do with the spent uranyl nitrate as part of this
So
process?
after we extract the thorium, the highly enriched uranium that's left is educted and downblended with depleted uranyl nitrate. We downblend to a ratio of 150:1. So,
Okay.
and then we have a process cycle. That's how much material we can stick into one of those big tanks that initially contains the depleted uranyl nitrate. As we downblend about 3 weeks worth of material, at the end of that cycle, we take a sample. We wait on the analytical results to confirm that we've met the waste acceptance criteria at Nevada, and then we solidify the material. There is a in situ blade in that tank, so we just add pure cement to it, blend it up. We let it cure for about 4 days, and then pull that out of the building, put it in a 21300 cask, and it gets shipped.
Good. What type of resin do you use in the columns, and what do you do with the spent resin?
Okay, I don't have an answer on the type of resin because I am not the civil engineer, remember? You do have chemies that work.
It's not an amberlite resin, is it?
No, it's not. But the resin, the resin is replaced every 2 to 3 weeks. And we put into the division cell, so the cell that's allowed to have where the solids come back to, we put in there a container of basically a blender container with cement in it. We put in the resin and a little after it's been rinsed with some water, and we blend it up and it becomes a solidified resin margarita, and it gets we take it out of the cell as debris. So it goes with the empty canisters that we have after we pour the oxide out of it, and all of that gets shipped out to Nevada as debris waste from the process.
Have any of the treatments been used in the U.S. for the prostate cancer?
Not that I'm aware of. Most of the trials are outside of the U.S. because they can get to stage 3 or level 3 trials faster.
Because I'm a product of a prostate cancer seed implanting, and it was not this material.
No, it was not.
So it does work. I've been cancer-free for several
Excellent.
years.
That's wonderful.
Yeah, the conversation answered my question. You had said in your presentation disposal, and my question was where, and you answered it in talking with. So I have no more questions.
Okay. Do you have any questions from the guest? Right. Thank you, Ms. Schaefer.
And nobody
Enjoyed the
online.
presentation. Yeah. Oh, I forgot online. I'm sorry, you guys didn't me tonight. Online.
We don't have any.
I'm sorry.
It's an S, but I'm not.
This is Mary. Can you guys hear me?
Yeah.
Yeah.
Yes.
Okay, first of all, I have to say this is so exciting. Around 40 years ago, I started my career in the pharmaceutical industry, worked for AstraZeneca and Lilly, and to see their names up there is exciting, especially with the hope for prostate cancer. So it's what a win-win for everyone. Question, but I think you're going to enjoy your career for 16 more years if this is the trajectory. So congratulations and good luck.
Well, thank you.
That's all I
Sarah,
got.
Could you comment on how many doses 40 grams of thorium equates to?
So 40 grams will equate to about 500,000 doses a year.
Oh, and one year.
Wow.
Thank you.
Is there anyone else? I don't see any hands up. Okay, Roger. Oh, I'm sorry. You got a question, Mr. Gibson?
Good question.
Yeah, I do have a question. We had quite a conversation ahead of time. I'm not get into all that about. We talked about some of the nuclear safety, aspects of the facility and
Yes.
really the workers are exposed to hazards and they have to be well managed and controlled by procedures and things.
Yes, absolutely.
And just an example, I think recently that the DNFSB did report that 2 personnel were contaminated. One of the what the depleted uranium nitrate tank handling getting where it was the survey done.
Well, yes, it was it wasn't from the tank itself. We bring in these tanks that are 25,000 pounds using an air pallet into the building, and we were moving that air pallet outside. It had been surveyed, 90% of it, except for one area where the RCTs could not reach. Our workers were getting the air pallet ready to receive a tank of depleted journal nitrate. The workers, knowing that think of it as an onion, that not every surface of that could have been surveyed. They were frequently surveying their hands, and one of our technicians did find contamination on their hand. We identified an area where we had some dripping of the prior tank of the depleted journal nitrate. And we deconned the hand. We've now put in some additional controls. So, and we've moved a couple of tanks since then. The other individual that was one of our folks who work on the manipulators. They were dealing with hundreds of thousands of DPM contamination. And when the millwright was doffing his PPE and going through the survey out, they found one spot on his finger that was 700 DPM. We have increased the RCT oversight. We never found PPE where there had been a penetration. Quite honestly, not sure how that got there on that individual, but we've elevated the RCT surveying when we're dealing with the manipulator repairs. Just to put that in context, over the last, since the beginning of this year, we've had those 2 instances, but we've had 7,000 sign-ins on RWP. So we do extensive rad work, though any contamination is too much. But we do have folks who are very focused on what they do and well-trained. We've learned that this U-233 is pretty sticky and have elevated some controls because of that.
Is this the only facility in the US that's doing this?
Yes. Nobody else. I mean, with the majority, the US's supply of uranium-233 minus a few one-offs is sitting at building 3019.
Okay.
Any other questions? Ms. Shirley, do we have any public comments?
We do have public comments. Mr. Gibson, if you want to come up.
Oh, yes, I'm Luther Gibson, as you know, former member of the board. I continue to review meeting materials from the other SSABs and make observations regarding the topics presented. And you know by now, it's not a secret that I'm not a fan of a single issue each month the board meets. At the Idaho Cleanup Project Citizens Advisory Board meeting on October 23rd, they received the following presentations. One was an Idaho Cleanup Project overview. Another was a 10-year plan and budget overview, which listed and detailed the individual task orders in the contract. They had an update on their Idaho Circular Disposal Facility, expansion of the existing cells and adding a third. They had an engineering evaluation cost analysis for D&D of a naval reactor facility prototype. And they did a circle overview of emphasis on groundwater, including one where they're doing in situ biometeration, like for trichloroethylene, like we're doing here. And maybe a unique problem, they have a expanded site hunting boundaries because the elk are coast tribal agricultural land out there. And their meeting materials also had a 4-page public outreach summary of events that occurred, including visits by officials, people like Senator Mike Crapo, I believe, outreach events to the media, naming individual contacts public affairs made, and other public meetings and documents that are undergoing comment or have been released, such as the annual radionuclide air emissions report and annual site environmental report. Their meetings appear to be about 3 times a year. They meet either all day or at least in the afternoon, and they have about 5 or 6 presentations. So arguably, they're getting as many presentations in one meeting as you get to in a year. And I'll just, I'll just make that point there. And I'll switch gears here to another thing. ORSOP boards and committee meeting dates have been reviewed in the past. In 2000, the board meeting was changed from the first Wednesday to the second Wednesday. And there was discussion about Wednesdays, but it was kept at that, although some people had other preferences. But one I'd like to suggest now is maybe considering moving the committee meeting to the following week, not 2 weeks later, as we did back in the past. Thank you.
And Mr. Conclusher?
Yeah, thanks. I suppose Doug Colclasure, 103 Monticello Road, Oak Ridge. Obviously, the in-state is a big part of all of our conversations for the site here. It may be interested for the board to know that one of the in-states is a new highly enriched low assay uranium processing facility. The construction on that started a week ago, and yesterday they moved the heavy equipment on site. TRISO-X facility that's nearing, I believe the NRC's given a permit, but it's close. It's right here at the edge of town. And the impetus for TRISO to start was $500 million from Amazon. So it's a pretty serious project, and it's 8 miles, 10 miles from us right here. 2 weeks ago, TBA was in Oak Ridge. Chairman Jeff Flash and senior staff presenting their integrated resource plan. It's open for public comment, and given the amount of electricity used in Oak Ridge, I think it'd be good to be a part of that process if you weren't at the public scoping meeting. It was 2 hours, excellent questions, very responsive TVA staff, totally knowledgeable engineers, and 6 different major computer models trying to predict the power needs for the next 25 years and the generating resources to meet those in an era of carbon sequestration reduction. The third item I wanted to briefly mention is the city of Oak Ridge has just launched their comprehensive planning process. Has it been completed in 25 or 30 years or longer. So given the presence of site in Oak Ridge, I think someone from the board may want to be a part of that if you aren't already. And the fourth item is greenways. I mentioned the greenways guy wanting to talk about greenways, but anyway. I think we should focus on how this site is and the parcels that are released for reindustrial are connected to a greenway system. For example, the Blount County and the Blount municipalities have an organization called Blount Partnership, but Brian Daniels is chairing that, or he's the president. And he made a presentation at the McGee Tyson board meeting not long ago, where he was working with McGee Tyson to get a greenway easement across the airport. And he made the point that the Blount Partnership promises every new company connection to their greenway system. So I'd like for the board to keep that in mind as a recommendation as far as, release of properties for reindustrialization. Thank you for your time.
Thank you, Mr. Plunkett.
We have no further public comment, but we'll continue to accept it for the record through Monday, the 18th.
All right. Do we have any requests for new action items? No requests. Okay, our next meeting is going to be March 12th. On ongoing efforts to assure waste disposal facility. And that will include the business portion of this portion. Need a motion to adjourn this motion.
No,
No, not a motion.
no, that ends the presentation.
Presentation. I'm sorry. Oh, I'm sorry. To approve the agenda. I don't need a motion to approve the agenda.
That's also at the,
Okay, it's on. Okay. All right, that concludes the presentation portion of the meeting. Thank you, the presenters.
They're free to
Did a
go.
great job before we go.
thank you.
All right, we're gonna go to board business. Has everyone had a minute to look over has everyone read the minutes for the October 9th meeting? All right, I need a motion to approve those. Second. All right, to approve. Okay.
All in
Roger, sorry,
all in favor to approve the minutes?
all in favor, I'm sorry. Y'all are stuck with me tonight.
That's okay.
I've never moderated a meeting.
It's okay, it's okay. We got hands up there, approve, and hands here. Do we have a quorum to approve the minutes?
We do.
What? We do.
With Harold.
Harold King, yeah.
He made it. Okay.
Okay, they were approved.
No, I just don't, they're still.
Approved?
Yeah.
All right. Roger, do you have responses to?
There are no outstanding recommendations, so there's no responses to comments on them. One thing I will point out is that we did get approval from headquarters for 2 site appointments to fill current vacancies. You can see one is lady named Lauren La Luzerne from Oak Ridge, and the other is Laurie Clark from Oak Ridge. For a variety of reasons, we weren't able to get their notification in time before the meeting. So they're not here tonight. They should be at our next meeting. And of course, the regular rotation of appointments, those folks their terms will start in December. They'll be here for February meeting? No,
March
meeting.
February.
Yeah, we're getting ready to take a big break here. So.
February will be the new member orientation.
Yeah,
And so current members will also be invited to come on that, and you'll get more information about scheduling on that as we get through it, probably in January.
Okay.
That's it. And as she pointed out, so after tonight, we don't see each other again until February, March. So we all leave. I just want to tell everybody have a happy holidays.
Wow, we just got them like,
Yeah.
like chickens.
Mhm.
Yeah.
Don't forget how to get here.
Okay, thank you. All right, the committee reports, we talked about new member recruitment is open or gonna be opening soon. If anyone knows of a potential candidate, get them in touch with Ms. Shelley. And then we discussed a holiday gathering for the board members on December the 11th. There will be more information coming out about that. I think they're trying to get the date set for the place, everything.
Yeah, Amy is not here, our chair, and she is working on that, but I will also help facilitate. So if y'all could just pencil in December the 11th. And
That's an
we'll get-
evening gathering.
I'm sorry.
That'll be in the evening.
Yes.
Okay.
We're gonna do it at a local restaurant. We've done it at Calhoun's before. We've done it at Aubrey's. We just have to see who has some space for us. And so,
It's a Dutch event.
a specific evening time will be announced once we figure out availability.
Okay.
And the next executive meeting is February 5th. I'll let Mr. Ward speak on the EM stewardship.
As far as reports go, there are none at this time. Our next meeting will be at March 26th.
2020.
Ways out. Okay, do we have any additions to the agenda? All right, thank you, guys. We'll see you, I guess, some of you next year. Sure. All right.
So motion,
Make a motion to adjourn the meeting.
Second,
First, we'll have first.
first, my first.
Second.
So
I
moved.
second.
Everybody in favor?
There you go. Thanks.
Raise your hand. All right.